Hello, everybody. Welcome to my channel, Island Daily. My name is Dr. Aman, and I'm an optometrist. And today we're going to understand everything about hard contact lens fitting. But before that, if you haven't watched my videos on contact lens introduction and soft contact lenses, go watch on my YouTube channel. All right. So first, you need to learn the difference between RGP lens. RGP means rigid gas permeable lenses and soft contact lenses and scleral lenses. So today we're only going to talk about RGP lenses, right? So these RGP lenses are smaller in diameter as compared to soft contact lenses, and of course, scleral lenses, they are pretty huge. And the material of these RGP lenses is quite very stiff, and they are stored in a container without a solution. So they're pretty thick, and it feels like you have a plastic on your cornea. However, soft contact lenses, as the name suggests, are pretty soft and they do not cause that much irritation. But the RGB lenses are so rigid and they do feel like a plastic that is placed onto your cornea. And these corners are going to lie on your cornea. So a soft contact lenses might be of HVID plus 2 millimeters, and RGB lenses might have a diameter of HVID minus 1.2 to 1.4 millimeters. So the edges are going to lie directly on the cornea. So they cause so much irritation. But the question is, why do we prescribe RGB lenses? If they are so uncomfortable for the patient, why do not we opt for the soft contact lenses? The reason is these RGB lenses, they will compensate 3 diopters of cylinder, and they also help in to halt progression of keratoconus. So now we will get into the fitting of these lenses. You can opt for dynamic fit or a static fitting technique. So in the dynamic technique, you will only see the movement of the lens after the blink, and through which you will opt for different diameters, and you will, it's kind of a hidden trial technique. However, in static fit, what you'll do is that you will measure the exact diameter, the centration, and then you will apply it on the patient, and then you will measure it with the observe it with the fluorescent pattern. Either it is a good fit, a steep fit, or a flat fit, and or an optimum fit. And we are looking for an ideal optimum fit, right? So now, since the contact lens is directly riding residing on the cornea, the air exchange is through the tear film, right? So the tear film, there is a tear lens between the hard contact lens and the cornea, due to which the hard contact lens can move 1 to 1.5 millimeters after blink, which was very constricted in the soft contact lenses, in which we had said that it can only move to 0.5 millimeters if it is an optimum fit, which means that it was not too flat or not too steep, right? But in hard contact lenses, 1 to 1.5 millimeters of movement is in the optimum fit. Why? Because the lens is residing directly on the cornea. The corners are on the cornea, right? and there is a tear lens between hard contact lens and the cornea, right? Now, we can use the fluorescein only in the hard contact lens, right? And not in the soft contact lens. Why? The reason is because soft contact lens absorbs the dye, right? And hard contact lenses doesn't absorb the dye. So now for the fitting, what things do we need to see, right? So in hard contact lens, you have to look for the fluorescein pattern. In an optimal fit, what you'll get is a quite fluorescein pattern in the periphery, which is actually the fluorescein clearance. And at the mid periphery, you might get bearing, and in the center, you will not see any fluorescein pooling in the center. If the fluorescein pools in the center, it means that this fit is steeper because the tear film is accumulating in the center. However, if the lens diameter is smaller, is greater, which means that it is flatter, you will see bearing in the center and clearance in the periphery, right? So you might want to look for an ideal fit. Now, as I've mentioned before, that you can compensate 3 diopter of cylinder in hard contact lenses. How is it possible? Well, you might have to do some calculations for it, but first I need to tell you something that is that when I speak of a K reading in hard contact lenses, I'm talking about K1. However, when I talked about K reading in the contact lenses, I was talking about the average of K1 and K2, right? Now, let's say if I have cylinder of 0 to 0.75 diopters, right? And I have a K reading of 41 and 42, right? K1 and K2. What I'm going to do is, let's say it makes 8.3 millimeters and this makes 8.4 millimeters. I'm supposing I haven't calculated it. So I'm going to fit the contact lens on the base curve 8.3 millimeters, right? Since 0.75 diopter of a cylinder is quite negligible and it can be compensated with the natural tear film, which is forming between the hard contact lens and the cornea, right? And you might not forget that 0.75 diopter is also compensated by the soft contact lenses, right? Okay. Now, if the cylinder is up to 1 diopter, right? What you're going to do is you're going to zero subtract 0.05 millimeter from the K1, which means if your K1 reading was 8.3 millimeters, 8.36, right? What you're going to do is you're going to subtract 8.36, 0.05 millimeter from 8.36, and you will get 8.31, and then you will look for the closest diameter in your trial frame kit, trial lens kit, right? Okay. What if your cylinder is from 1 to 2.5 diopters? Now, what you will do is you will subtract 0.1 millimeter from the K1, which means if your diameter was 8.36 millimeters, you will going to minus 0.1 and you will get 8.26 millimeters, right? Now, if your cylinder is between 2.5 diopter to 3 diopter, what you're going to do is you are going to take the average of the K reading, which means you are going to do what? 8.3 to 8.4 divided by 2, and let's say it makes 8.3.5, right? 8 8.3 8.35. And so this is going to be your base curve, right? Now there is one important question. How are you going to decide the power of the contact, right? Now what if there is a prescription which is less than 4 diopters and the prescription is minus 2.5? So what you're going to do is you are going to opt for 5 diopters of power. Why? Because it is less than 4 diopters. You are not going to adjust the BVP for that. If the power was greater than 4 diopters, then you will have to opt for the BVP chart, or you can calculate it for yourself with the formula FSP or 1 minus DFSP, right? Right. Now what? What if the prescription is a sphere cylinder prescription, right? And it is also less than 4 diopter. The sphere is less than 4 diopter. So let's say if the prescription is minus, sorry, minus 2.5 and minus, sorry, plus, right? So the first thing that you need to do is you have to transpose it in negative cylinder form. So what you're going to do is I will transpose it and I will get minus 1.5 minus 1 at 90, right? So since the sphere is less than 4 diopters, I'm not going to opt for go for the BVP, right? But what I'm going to do for with the cylinder, as I've mentioned before, that for 1 diopter, what I'm going to do is I will subtract 0.05 millimeter from the base curve, right? So the base curve was 8.36. I will subtract 0.05 millimeter and I will get 8.31 millimeter. And then what? I will drop the cylinder. So now the power of this contact lens will be minus 1.5 diopter sphere and no adjustment for the BVP, right? And I have adjusted the cylinder in my tear lens prescription with the help of my tear lens, right? Now, what if power of the sphere cylinder is greater than 4 diopters? Now, let's say, what if the power is minus 8 diopter sphere? What you're going to do? You are going to subtract, you are going to adjust it for the BVP, right? What you'll get is you'll get minus 7.25 diopter sphere, right? So this is going to be the power of your contact lens, right? Now, what if you had a sphere cylinder greater than 4 diopters? It's also a sphere cylinder. What you're going to do, let's say if you have a power of plus 10 with plus 2 diopter at 180. What you're going to do, as I've told you before, you will transpose this in the negative cylinder form and you will get plus 12 minus 2 at 90. Now what? First, you will have to adjust the BVP for plus 12 diopter, right? You will adjust the BVP for the 12 diopter and you will get plus 14 diopter sphere, right? Now, what for the minus 2 diopter sphere? You will subtract 0.1 millimeter from the base curve. So let's say if the base curve was 8.36, you will subtract 0.1 millimeter and you will get 8.26 millimeters. And now you have to drop the cylinder and you will get 14 diopter sphere with no cylinder because the cylinder is compensated by the tear lens, right? Now, there is one last thing that I need to tell you, that if you are making your contact lens C by 0.05 millimeters, you are actually increasing that power, right? You are actually adding 0.25 diopter sphere per each 0.05 millimeter steeper contact lens. And so if you are making fatter by 0.05 millimeters, you are going, you are subtracting 0.25 diopter sphere of power from your contact lens, right? So what you will do in the final prescription is, in the final prescription, let's say if, let's take the scenario. So the prescription here was, let's take it, talk right here. So we had it right over here. Yeah. So we had made it 0.05 millimeter steeper, right? We have subtracted it and we have made it steeper by 0.05 millimeter. Now what I'm going to do is, I've added the power of the tear lens. Now I will do what? I will subtract 0.25 from the prescription and I will get 1.25 diopter sphere, right? Because what I have made it steeper. Now there is extra power lying in the tear lens. Now I have to subtract it from the main contact lens power, right? Since this is an ideal fit, so we are not going to touch the prescription. We are just going to opt for the BVP. Now here, now what? Here, what? We have made it 0.1 millimeter steeper, right? Which means that what do we have to subtract, this was the power, we have to subtract minus 0.5 diopter sphere and we will get 13.5 diopter sphere, right? Because we have made it 0.1 millimeter steeper and now there is plus 0.5 diopter sphere of power in the tear lens. For that, I have to make the prescription a little less so that the adjusted tear lens power might not overcorrect the main prescription, right? So this was the whole lecture. I hope I have made everything clear. In the next video, I will tell you different patterns which you might able to see during the contact lens fitting. And if you haven't watched my contact lens introduction video and soft contact lens fitting, it is in on my YouTube channel. It will help you in understanding and relearning the basics of the contact lenses. So I hope the video went well. Thank you for watching and do share it with your peers. Thank you very much.